Okay, today we are continuing in 12.3, divide polynomials, and then we're going to take it the next step. So, let's go back and recall yesterday. Yesterday we were dividing, and we learned how to use long division, dividing a polynomial by a monomial, and then we divided a trinomial by a binomial, right? Using the leading term as our guide, as we did that, right? And now today, the next little step before we get into the more interesting piece here is you might receive the expressions looking like this. And how are these different than what we were working with yesterday? Do you see the difference? What's different, Tom? It's not in the correct order. And the correct order is called standard form, right? And so when we have standard form, we have what you see here. Exponents are decreasing left to right. So let's rewrite this in standard form. And the first term would be? Second term?
Minus 3n minus 21.
Divided by?
N plus 3.
Okay, and let's go do that. Let's do this division. So, okay, so when we have these two in standard form, we look at the leading term. Kyle, I know you weren't here yesterday, so I'm going to ask you now. We look at this first term in the binomial. We look at n, right? And what would I have to multiply to n to get to n squared? So we're going to multiply that by n. And we're going to place it over the first degree term, 3n, negative 3n, right? Just to keep them lined up by degree. So when we do that, though, we're going to multiply n to both n and plus 3. So what is n times n?
N squared.
And what is n times 3?
3n.
3n. Okay, so I'm going to erase that because we have more to do. But we have n squared plus 3n. So because this is division, we subtract this line. And we subtract the whole line. So I'm putting it in parentheses. And so we have n squared minus n squared, which is nothing, 0, right? And then we also have negative 3n minus 3n now. And what is that? Negative 6n. Good. Okay. Now, the next step is we could drop down the next term, negative 21. Just bring it straight down like we would in division. And we're still using the leading term to guide us. So what am I going to multiply n by to get to negative 6n? Negative 6, right? So when we multiply negative 6 times n, we get negative 6n. But when we multiply negative 6 times 3, we get negative 18. Now remember, because they are the same, negative 6n and negative 6n, we have to subtract them, right? So when we subtract negative 6n, we're really adding 6n to negative 6n, which is 0, right? And then we're subtracting negative 18, which is really adding 18, right? What is negative 21 plus 18? Negative 3. Now, can we multiply n to anything to create a negative 3? No. So this is where we have a remainder, right? So we bring the remainder up, and we say we add the remainder to the term that we have. We can say we have negative 3, which is still being divided by n plus 3. Okay, so this is just a review of yesterday, and hopefully that makes sense. You have to do a few in order for it to feel better. This one looks a little bit different because we have a binomial divided by a binomial. And yet the first binomial, what's the degree of this binomial here? Second degree. So what kind of an equation would that be if it was set equal to y? If y equals negative 12 plus 4y squared, that's what type? Quadratic, right? Quadratic. And usually with quadratic equations, we have trinomials, right? So there's something a little extra different about this, but let's start by putting it into decreasing exponent form, okay, or standard form. So the first term would be, Oscar?
4y squared minus 12.
And then the second minus 12. Okay, and then we're dividing by
2y.
Let me redo that so I'm not, whoops. We're dividing by 2y minus 1. Now the only, there is a problem with this. Look at what happens. What would we multiply 2y by to get to 4y squared? 2y. Now where do we normally put that value?
Oh, under the same.
Under the same degree term. Do you see that this binomial inside of the radical, or inside of the quotient thing, there's a special name for that thing and I'm forgetting it. No, it's a really weird name, begins with a V. There's like a few, but anyway, there's no, just a single degree term here. Do you see that? So when you have a binomial that's a second degree like this, we could rewrite it. And we could say this, 4y squared plus, how many y's do we have? Just plain old y's. 0 y's, right? Minus 12. And now we're going to divide that by 2y minus 1. So we're expanding this out. We don't have any y's, but we now have that place. It's kind of a place value, isn't it? Okay, so why do we do that? How do we do it? We got 0 y's. We just added 0 y's. Is 0 y equal to anything? What does 0 y equal? 0. It just provides us that place. You can do that. You can add 0 anything you want. You can add 0 to anything you want, and it will remain the same, right? Is that simplified form? Is that simplified form? No, this is not simplified. This trinomial in here is not simplified, but it's providing us with a space to show each of the possible degrees you would find in a quadratic, right? So when we do 2y, you said times 2y gives you 4y squared. We now have that place available to us. That's all. Okay? So when we multiply that 2y times this binomial over here, we get 4y squared minus 2y. And we have room. When we subtract this, we're subtracting each. So subtracting 4y, nothing. But when we subtract the negative 2y, what do we have? Positive. And now we drop down to negative 12. And now what do we multiply 2y by to get to 2y?
1.
So it's a positive 1, right? And now, again, we're going to multiply 2y times 1 and negative 1 times 1. Negative 1. And don't forget, subtract both of these terms. This is where a couple of you had issues with your negatives last night. We just saw in homework. You got to put these parentheses and subtract each, especially the second term here. When we have negative 12 minus a negative 1, we have negative 12 plus 1, which is negative 11. And so there's our remainder, negative 11, which we can say is, we can subtract 11 over 2y minus 1. Or we could write plus negative 11 over 2y minus 1. Either way. Questions?
Wait, so
Okay, so this is where we get to use our division and then graph. And you're going to really see how easy this is. It's really fun. So the original equation says y equals 2x plus 1 over x minus 1. So we're going to stop and not just make a table. We're going to go ahead and do the division. That's what that fraction is saying, so let's divide. 2x plus 1 divided by x minus 1. So x times what gives us 2x? 2. But remember, we've got to multiply 2 to the whole divisor. So what do we get?
negative 2x minus 1.
We don't get negative 2.
Yeah, 2x minus 1.
We get 2x, not minus 1.
2 times negative 1.
2 times each.
Negative 2.
Oh.
Negative 2.
Oh, good.
Understand?
Yeah, I know now.
Okay, now we're going to subtract 2x minus 2x and 1 minus negative 2, which is 3. So, again, we have a remainder. X times what would equal 3? There's no way to give a value, so we'll say plus 3 over x minus 1. If you have a comment, raise your hand. Okay, so remember, this quotient we just found equals that expression there. So the entire thing equals y. We can write this just like that, but we can also use our commutative property of addition to bring the fraction closer to the y. And that's what we're going to do. We're going to rewrite this and put it down here. Y equals, using the commutative property of addition, give me the fraction first. What is it? 3 minus 1. And then we're going to move the 2 over here. And now we have the model of a rational function that you've been graphing, right? So let's look at this. What is the horizontal asymptote? You remember? 2, right? There it is, K, out there. So we could draw that in. What is the vertical asymptote? Or what value is not permitted in the domain? 1. So there you have it there. Okay? And then is this going to be, so we see by these asymptotes that we have a translation up, 2, and a translation to the right, 1. And do we have any other transformations from the parent? Do you see a reflection or a stretch or a shrink?
Oh, stretch.
A stretch of a factor of 3. There it is. Okay, so now we could just make a table and finish the graph, making sure we don't cross these asymptotes, right? So let's do that. I'm going to make a table, and the value we said that is undefined is 1. So we want a fraction on either side of it. It would be nice even to have 2, but what's a little bit smaller than 1? You could say 1/2. And then a little smaller, we could say 0, right? And maybe -1. How about -2? What is -2 minus 1? -3. That's easier to go into 3. See that? So I'm going to say -2. And then in the other direction, we would want to go a half greater, so that's what, 3/2? Or 1.5? And then maybe 2. 2 minus 1. And then how could we make this whole value be equal to 3? What would x be? 4 minus 1? Good. 4. So I'm going to pause and find these values. Okay, so there we just got a few values, and we know we may not cross those asymptotes. That's critical. And if the book does not ask you to draw them in, please draw them in. Please do it, because that really tells me that you know where this graph is, where these branches are. It's important. We could describe the transformations you already did. You said that this is a vertical stretch. The factor was 3. We said it was a translation up to 2 and to the right 1. And that was all. Okay. And let's try one more. We're going to try this one here. Come back and look at the answer when you have tried it. Okay, so 8th grade. This is what we found, which is good. What is a transformation from the parent? Based on the fact that we are now in quadrants 2 and 4, we have a reflection. So look at our equation. This was the equation, y equals -2. -2 gives you that reflection, right? Reflection in the x-axis. And then, do we have a stretch or shrink? Yes. What is it? Stretch, factor of 2. And we have
Translation up, down,
Cameron to the left, 1. Okay, good. And there you go.